Proofs are fundamental in this course, and I want to say now a little bit about what a proof is, why we use proofs, history of proofs, and so on. So the proof of a theorem is a sequence of statements, in principle, and each of those statements is either an axiom, one of the assumptions that we make in the case of arithmetic, or one of the assumptions we make in the case of the real numbers, or similarly in other areas of mathematics, or the statement, each one of the statements in the proof, is an assumption that we've made in the theorem. The theorem will usually be of the form, if such and such, then blah, blah, blah. And we can write down such and such as one of the statements in the proof. Or the statement is one which follows from earlier statements in the proof using the rules of logic. When we write out a proof, we use a mixture of English and mathematics symbols. We don't just write it in mathematical symbols. That would be pretty incomprehensible to a human being. Question is, how much detail? Well, that's a difficult question to answer because it's going to depend on the level at which you are. At the beginning, you should put in a lot of detail. Make sure that there are no gaps. As you proceed and you do more mathematics, you'll find things more obvious, and then it's not as necessary to put in as much detail. Indeed, you should not put in unnecessary detail, because after all, we're human beings reading the proof, we're not computers reading the proof. There's a little bit of terminology that occurs in mathematics, and particularly in proofs. A theorem is a major result. A proposition is perhaps a less major result. A lemma is often a result which is proved on the way to proving a theorem, and a corollary is often something which is the result of a theorem. But the terminology varies. Why proofs? Well, proofs are to guard against making mistakes. There's a certain absolute certainty about a well-written proof. It should not really be open to argument. And if one is challenged, one should be able to fill in any of the missing details. A proof is also a means of checking our own understanding and our own arguments. There's always a possibility that we'll make mistakes, of course, but in principle, we should be able to check the veracity of our own proofs. And if we are unsure about a particular statement, then we need to put in more detail. And a proof is certainly not just a plausibility argument. A proof is not a stream of consciousness. Searching for proofs, on the other hand, and in fact, we often make mistakes, and we learn from our mistakes when we're looking for proofs. There's a nice discussion in looking for proofs and mathematical reasoning in one of the MOOCs, and I've given a link to that below. Euclid's Elements are probably the first example historically of proofs. This is about 400 BC. This is amazing, so far back. I've given some links to translations of Euclid's Elements. There was no improvement probably for about 1,500 years. There are many examples in this course of proofs, and I've again given some indications below in the file below of some proofs in particular you may like to have a glance at this stage. And finally, proofs, as I said before, are a way of making sure that our arguments are correct. Proofs also help us understand, in certain cases, the result of the theorem. A nice proof is often one which gives us some insight into the theorem, and it also helps us in often applying theorems elsewhere.